हॅलो हॅलो Hello. Hello. Am I audible?
Yes, sir. Voice is coming.
Is
Yes,
okay?
sir.
Okay, good morning to everybody. Now we are on the final day of the FDP in applied mathematics. So, applied mathematics in interdisciplinary research, theory and computation. In the first session, we have the esteemed expert Dr. Ashish Rautre, and he will talk about on an introduction to data assimilation system. And this topic is very helpful, particularly those are working in numerical weather prediction. And it is also very helpful for the students those are working in numerical analysis, since the initial value problem, whether it is ordinary differential equation or a partial differential equation, and how to improve the initial conditions with the various techniques, particularly in models, whether they are mesoscale models or a global model. And now with the application of data assimilation, we have improved the various qualitative results. So he will talk about the basics of data assimilation and the brief about the speaker Dr. Ashish Rautre. And I am very happy to say about the brief Dr. Ashish Rautre. First of all, he is my good friend, and he is my basically we did PhD both from the same department from IIT Delhi, and he did MSc in mathematics, MTech in atmospheric science, and presently scientist staff is National Center for Medium Range Weather Forecasting under Ministry of Earth Science, and where we have a computational facility in India, we can say on the first rank in that, and even number 2 in world. And Dr. Ashish Rautre is an expert of data assimilation, and he has published more than 60 papers in reputed journals, and many of the journals have the impact factor more than 5. And he has also guided various PhD students, MTech students, and I am sharing the very good thing about him, and he's a very nice person also. And secondly, we have also jointly supervised 2 PhD students, and 1 PhD student is working under in my and Dr. Ashish Rautre guidance. I welcome to Dr. Ashish Rautre in the Department of Applied Mathematics. He find a valuable time. He is a very busy nowadays. He has a lot of responsibility from his organization side, and I am very grateful to him. He find a time to give about the introduction and basics of the data assimilation system for the faculty members in the research projects and all the participants, those are joining online or offline in conference room. Thank you very much, sir. I invite Dr. Ashish Rautre to start your talk. Thank you, sir, for joining us. For joining, I request to Mr. Arun Kumar, please give just a small token of as a welcome to Dr. Ashish Rautre, and please give a good photograph. Thank you, Arun. But he is my good friend.
mathematics, and I also did in STEM. About talk about each other, but I will be more in a scientific way because he's a mathematician. I am also atmosphere science. How will closely work? So this is basic of data acquisition because I will not go very detail of the data acquisition. You people will get go because this is a new topic for you people, but you will be interesting how your mathematics is the real world problem solving. Okay, so in this regard, I'll go one by one, and if you have any doubt in between, you can ask any question, the higher or very basic, whatever you can discuss because this is FDP. We have to develop ourselves. It's not just talk and they go out. It's a development ourselves. So next. So I cover about NWP model briefly because yesterday Dr. Abhijit Sarkar has given about detail about the NWP model. Then data assimilation, why you will going for data not NWP can solve this problem. Why will go jump into another problem? And nowadays it's very important variational data. What is the variational data assimilation? Why it is important and why people are doing this? Then difference between different variational data assimilation, mathematical and physical significance of between them, and hybrid. When we are talking about hybrid, then we combine both things and get whether this result will get why is the limitation of each variational, then what is the benefit. So I'll briefly one slide I am showing what is NWP model. We have a mathematical equation because in the NWP model, we know the primitive equation, we have a 7 equation, 7 variables. You know algebra, if you have a 7 equation, if you have no 7 variables, you cannot. No. If you have a 7 variable but 6 equation, you cannot. So this is the basic mechanism. What is happening in atmosphere, day-to-day life? If you have a something is happening, whether this will impact to other variables, 7 variables. U, V, W, P, Q, and density. So here we introduce another variable density because we have to solve these 7 variables. So P is equal to rho r. Very simple equation. Yes or no? Then if I have to go to mathematics people, I am also mathematics MSc. So people ask me what is Navier-Stokes equation. I wrote 2 to 3 lines of Navier-Stokes equation. Yes or no? When I came to IIT Delhi, he asked me, madam, his guide asked me, can you write a Navier-Stokes equation? I wrote 2 lines of Navier-Stokes. Okay. Then Professor Dubey told, yeah, what you wrote? Because sir, this is Navier-Stokes equation. No, this is not Navier-Stokes equation. And I told, no, this is Navier-Stokes equation. But one meteorologist told, this is not an Navier-Stokes equation. And I said, where is the confusion? You got me? So I am writing it is a Navier-Stokes equation. But he is telling this is not a Navier-Stokes equation. Then where is issue? Issue is which parameter, because mathematician cannot delete any term. They are writing every term, each and each. But one meteorologist can avoid certain term because you will compare scale analysis. Compare if my U is 15 meter per second, if my W is 1 meter per second, why I consider this variation is high rather than the vertical motion. So I will not consider that. If I go to fiction, if I have a horizontal fiction, vertical fiction, or meridional fiction, it X, Y, Z, then I will consider there is no fiction of vertical. So I will slowly, I will delete certain term. Then Navier-Stokes equation become a 4-digit number. Okay, one is the right side and 3 term is the left side. So then these 3 terms is used for meteorology but not mathematics. So that's why Navier-Stokes equation may not be correct for a meteorologist because you will take a scale analysis. So all these 7 equations, if you have to solve it, then what is issue in to solve? solving his issue is non-linear. How you solve this non-linear equation? Can you solve in non-linear equation in a pen and paper? Yes, I can do it. But my time is limited. I have to give forecast before 10 o'clock. Yes or no? So I cannot solve this whole night, day and night. Then day is over. For meteorologist, day is a very precious. I have to have given forecast 10 o'clock for 3 days. Okay, so this equation combines fluid mechanics and thermodynamics. Then one question will be how we will combine these two equations, thermodynamics and fluid mechanics. Yes or no? If you are thinking about thermodynamics, P or Q and T is a thermodynamic parameter. So question will come, who is culprit in the atmosphere? What is happening in the yesterday evening and all this? Who is culprit of the atmosphere? Only one variable Q. If when Q is changing its phase, water is changing phase. If have a water will going to ice, then what will happen? It will absorb the temperature. If the ice to water, then it will be some vapor, then it will release the atmosphere. This conversion, sublimation, vaporization, all this is releasing the temperature or absorbing temperature. So this changing of water vapor to one phase to another, that is the other parameter. So this convert them to form where they can be programmed into lab. I know I am solving this equation, but it should be a properly programmed. And with the time down, how will we parallel this equation? How will we solve this equation? After that, the software representation of the atmosphere involved within the computer. Then only we can solve this NWT. Okay. If only the equation and there is no computer, we cannot say it is a numerical equation. So in that concept, we will go, because this is an interdisciplinary subject. It is not only depend upon the mathematics, it depends upon physics, it depends upon also chemistry, it depends upon biology. Nowadays we are have knowledge, so we are incorporating. So end up with a combination of all the along with it. If we mathematician can solve, then if it is not computer programming, then we cannot solve the end up. So then this picture is very beautiful picture. People laugh this fellow. Who is sitting here? He is the father of the endeavor. That time the people don't. This is a mathematics. This is a big stadium. All mathematicians sitting in the 3-story stadium, and 64,000 computers are there, calculator. I gave Sushil, you solve this diffusion equation. I give Arun, you solve the advection equation. And I am the main person, I am collecting. Okay, what is your answer? Okay, 5. What is your answer? 6. Then I combine all 64, then I have given you answer. This is 9. 46 temperature, pressure will be varied. Then there is no. But this was the life parallel computing. How you combine all the information? Computer means parallel, you will collect it everywhere. Information. Then give a one solution. Right? So this reaction has massive parallel process. That time people are laugh. Say, what he is doing? He is a mad person, but he is the father of the. And he is so as called reaction forecast. 64,000 people are there. So can you tell this will be enough? No. It's a starting away from it. So then some algorithm is applied, round up, truncation error, because I cannot say 64.00070. So this is the problem create that slowly people solve. How will we solve this problem? So to solve this problem, identify, understand. I have to understand the thing, what is happening in it. Then mathematical representation of this. If you have some atmosphere changing, same mathematical formulation, same technology, same understanding will not happen. If I am working in cyclone, then I will apply 1,000 kilometers. If somebody is working in climate in time scale or spatial scale, he is thinking about all over the world. Yes or no? If somebody is thinking about the thunderstorm over the Gautam Buddha University, he will not thinking about what happening in Noida. He will focus on the Gautam Buddha. So I have to understand what is the process is happening, where I am giving importance, what equation has played a major role, what parameter will be play major. So mathematical equation, physical process, different weather has a different process. Then initial condition, observation, analysis, initialization. So in this all this knowledge, then I have to have initial condition. So that is very important. I'll talk about what is the initial condition, how it is important for the mathematical solution. Yes or no? You people already know. So then numerical solution, then statistical, then you see the picture. Then can you tell me what computer knows? Can you tell anyone? What computer knows? If I will provide some information, computer knows only arithmetic, plus, minus, multiplication, division, nothing else. You don't think the computer, we are doing computer, it is no, computer does not know anything, only plus, minus, division and multiplication, arithmetic. Then how you solve your calculus? How you solve your differential equation? I'm giving to computer programming area, computer kar diya. The computer knows only arithmetic, plus, minus, and it does not know d by dx. It does not know integration. It does not know calculus. You people mathematics. How will you solve this thing? So we have to convert this calculus, all these to arithmetic way. When you convert certain things to arithmetic way, you have to somewhere you have to compromise. How you solve a non-linear equation? You solve your laminar flow in a pipe, but how you solve a turbulent flow in your pipe? Can you solve? Yes or no? So these equations are all non-linear. So when you have a non-linearity, then we have a problem. So then non-linearity, okay, I am capable, I have some approximation, I have some algorithm, I know mathematics, I am not going that because you know the solving partial differential, all these equations, Taylorian function, or all the coefficients, Fourier transform, you know. And after solving this equation, I cannot do that without computer because atmosphere is not a one point. You people are serving one source and one thing. If something is happened, source, then you will have a thing. But atmosphere is same way, source and thing, but in a 3 dimension. Yes, my point. Get my point. It is not a 2D, it is a 3 dimension. Horizontally it will be vary, vertically it will be vary, and meridionally it will be vary. And another term is with time it is also vary. So the model is this atmosphere is a 4-dimensional model. So this is the schematic how this atmosphere, how you solve the equation is not a one point, each and each level, each and horizontally. So it's a huge matrix. Okay. So then after that, okay, I know, okay, I solve this, all these things, but different types of weather is yesterday, that's some. In Noida, we got lot of rain yesterday, but I told you, it's a light day, strong wind, adha ped toot gaya. Then you got, what is the kilometer within this Noida and Gautam Buddha? Around 30 kilometers. Then, yes or no? Within that 30 kilometer range, this is destroyed all these things, but you have a enjoy cold wind from Noida. So today or yesterday you didn't put your AC on because cool wind. Okay, but we suffer not. All night there is no current. So that type of variation, how you will be incorporating the model. within the 30 kilometers. So low pressure, the bigger region, then situation, bigger region, something. So this type of problem is actually, and you understand that problem, and accordingly you act. Okay. So then question, you understand? Up to this, I am giving the background. What is happening? Why I am going to initial problem? What is the importance of NWT? Why I am going to data assimilation? That is the background. The real play will be from here. So then there are two main sources of error in NWT. Because I talk about equation, because you are somewhere you have round up, somewhere you have approximation. Yes or no? To solve your partial differences. Yes or no? Can you solve it directly without any approximation? No, we have to approximate somewhere. That is just some error. Yes or no? I introduced when solving my mathematical problem. Physics of error. I could not understand what is happening within the under some processes. Because why is Gautam Buddha Greater Noida is not getting that yesterday thunderstorm? Why Noida got strong thunderstorm? Right? Physics is there. What atmosphere changes it? There is no barrier. You know, atmosphere is a continuum process. It's not follow this Bangladesh is a Pakistan is a no, it's a continuum process. What happened? There is a barrier. Yes or no? After that, it will not happen. After that, it will not. So that understanding we have a limit. Okay. What happening within that region and within 20 kilometers, 600 sometimes, you know. And another story, if you have a tornado is coming, you went to your market 5 kilometers away. When you back, there is no house in your colony. Imagine within half an hour. May not be no. Okay. So this type of things you have to understand. Those things are very important to understand. The initial issue, mathematical game. Then question will come. One kingdom is lost. Last line. Don't read that. One kingdom was lost because they have a good heart, they have a good pilot, they have a good soldier, they have a good management, but still the kingdom was lost. Then king analyze why we have lost. We have a Rana Pratap, we have a Chetak, everything we have, but still we lost that thing. Then he analyzed, he asked, you are the most proficient soldier and you fight 10, 20 people. Then he told, no, sir. Oh. Maharaj, because my horse was not stable. Where I ride, horse was not stable. Why horse is not stable? Because horse is good. Why is it not happening? No. Then the horse, what happened? Then this horse is like this way, simple. So what happened? The good horse, health is good, everything. What happened? Horse have a soul. One soul is there. Yes or no? If you have a seahorse, as a nal, we are telling nal. People have so one metal was there. So that nail was. For a 30 minutes, the shoe was down. For a bad shoe, the horse was down. Because you still नहीं चल रहे ना. So, and a horse unstable, the rider was weak. If I want a strong rider, the battle was weak. Even though he is a strong rider, the battle was weak. It's very easy. Issue is a small lift. I didn't purchase 10 rupees nail, I purchased a 1 rupees nail. So for that, so I have a big computer, I have a good mathematician, you people, I have a good physician, I have a lot of knowledge, I have a great people to work. It's very easy. Issue is my initial thing. whatever equation you solve, whatever you think, if my initial problem is, initial value is गलत है, तो automatically it will come in output. Okay, so in that base, you imagine small nail is the lost a kingdom. So don't ignore a small error. I am top out 4.035 pi. I will not solve the question. No. Computer is developing how preciously, how decimal it will be calculated. Okay. Big computer, big parallel processing, it depends upon how precisely it will be calculated. How so-called round up, not 2 digits, 16 digits, 64 bytes. You know, 64, 32 bytes, all this. So, in that small context, I'll start my real time. You understand? A very small nail can lose a big kingdom. So, problem in NWB in profit. We are investing profit, yes or no? So, total change profit. Now, 2 o'clock, we have a 100 2 to 5 o'clock. Imagine another 2 to 4 hours. So, immediately you have a clear. So, total hours problem, yes or no? You cannot capture that information with variation, with information. Then, after some dynamic, when the physical process is changing, I could not capture the dynamics. How it will be affected to another parameter. How much it will affect to another. How it will consequently happen. So that knowledge is not affected. Certain changes of physical process. That time will take. Well, okay, you do it bad with me. Time will take care. Yes or no? Same way, when there is a physical process, certain change of physical process, the dynamical variation is not able to understand that changes. How the mathematical equation understand? You have a time variation, right? You have a physical process. Or if you have a decimal change, heat temperature, then you will be back. So that process is not understood. But question is comes. American people can predict snow blizzard will happen in your house roof at 5:32, 6 o'clock. Why one meteorologist, why one Indian scientist cannot predict this thunderstorm attack your GBU at this time and at this time will be finished. It's a joke. Understand on things. Your extratropic region is a smooth way variation. Mass is varying. It's a big mass is varying from one place to another. But here, some mass is developed here in Noida, but it is not open to the industry. Okay, so this type of certain effort to change all these stochastic changes, all these variations, complex atmosphere, complex mathematics is involving in this. So that's why we are not able to capture this type of thing. But winter rainfall, exactly we have tell you. The coastal disturbance is coming, this will happen today, then it will go to northeast, because this is a large mass is moving. But here, it's a very small, localized. If you are coming from village, you have see, if you have a playground, there is a small turbulence, paper, newspaper, photograph paper, it is green, it is a small successive changes. नहीं, ऐसे घूमते नहीं, देखा नहीं. आजकल बच्चे तो टाउन हो गए, लेकिन हम गांव में जैसे खेलते थे, वो ऐसे नहीं, हम बोलते खंडिया भूत है. नहीं, हम बोलते अरे खंडिया भूत है. मैंने जिसका कटा हुआ एक थोड़ा सा एरिया को ऐसे करके पूरा लॉन्ग एटमॉस्फेयर तक चला जाता है कागज से. अदर सराउंडिंग इज नॉट same solar radiation, same characteristic of vegetation, same soil structure, same field, changes. So how you will capture that small? So in that, so what will happen? If we have a mathematical knowledge, we have a computer, but we have a less amount of observation. we have to observe the atmosphere, each and each breeze. Okay, you imagine there is no observatory in your Gautam Buddha University. There is no temperature because whole Noida is a one temperature. Is it true? It's true. If you come out your this road, you will feel I'm in the oven. But when we enter your university, the temperature immediately up on 20 minutes, 23 to AC गाड़ी में चला रहे थे ना 26 रखा था. नहीं गाड़ी जैसे रखा हुआ आ गया 25. Imagine how 1 degree, 0.5 1 degree variation within a 200 meters. But whole Noida, only one observatory in my office. Then how much do you understand? So now we are planning one stick from radar will be stick in your roof. It will observe all that. It will be modulate. It will be assimilate that information. So we need this type of observation, highly dense observation. Slowly, government of India is putting all the education. We are promoting you people to take care of this. Young students, you can do your dissertation in the Doppler radar. So many instruments will come to this institute slowly. So after getting this all observations, then another you talk about satellite failure हो गया मेरा internet नहीं काम करे all. You observe all the satellites, all observations. Then question is, I got mathematical knowledge, I got a computer, then I got a huge chunk of observation. I can say chunk of observation. Everybody put in my bag so many balls. Whether this ball is useful or not, I open my bag. People will put there. I have to cut out. Then question, how will you cut out? I cannot cut out myself. I have to follow certain rule, algorithm, regulation, yes or no? So to cut out that problem, thousands, million of data is coming to every 5 minutes. How you will actually? Because already I have a burden of the nonlinear. I have a burden to solve in a bigger grid. So to that quality control package is there. How will you quality control? How will you handle? That is a big. The mathematician can develop the algorithm. Computer people develop the algorithm. Then AI people develop the algorithm. Then the role of a mathematician comes to the picture. Right? Not to the solve the problem. Richardson solved the problem. But now the situation is we have a lot of observation. We have a Doppler radar here. Who will take care? How will be quality control? Because all observation has not good quality. So the mathematician, then computer science people to understand. Then combined with meteorologists, they have the knowledge. Yes or no? So these things is happening. Huge amount of data is coming. Information is coming. How to incorporate these things? That information is not very simple. I have information, I will add this information to my model. But how will I add the model? Okay. So that model we have to think about it could be physically, dynamically. Yes or no? If I increase a 1 degree temperature, I should understand what will be impact to Q, my moisture, what will be impact to U, what will impact to G, what will impact to S. If I could not understand, then I take it out and that. Okay? So this is not way. So this is another issue. When people thinking something more, then it is not incorporating more problem to their own box. One is in nonlinearity, then another huge amount of information. So assimilation is a technique, observational data. I got various observational data. Combined with the output, we have a mathematical equation. We got that information. We add that information. Because we know observation is good, NW product is a guidance. So we can modify that value with the observation. Okay. So as I am getting better estimate of a state of a system. State means initial. Simple example, you are people, 20 people are here. I can show you can start running. Who will be 100 meter complete? If you start from your chair, how I will think who will win? I can. So I will demark a one line and L line. Everybody can start here and this here. So that is the initial line. You will ask, no, sir, how is he will be or he will be first? I was in last bench. She was in first bench. So how could we see first? So I will draw a line. That line is initial state. Starting. So when we have solved a equation, we have to have a state of atmosphere. If I know proper way of atmosphere, then I can inform my equation. Equation is same for me, for him, for her. Equation is same. Equation solve is same. But how I am giving the information to the equation? If you have solved a Eulerian equation, if you have solved the Newton-Stant method, what is your x value? Can you tell? If you have a given y is equal to mx, you solve it. Immediately let x is equal to 1, y is equal to 1. Y is equal to 1. Who told to take 1? Why not 0.5? Why not 1 by 2? Any natural number? Any real number? Is there any confusion? Why I am taking 1? So this type of question, initial equation is same, but if I have a good observation, if I have a good quality observation, then I have given information to the other. If I have a good ingredient, then my chicken curry will be good. Yes or no? So in the question, when we have incorporated some observation, then question is, so they know solution will be better, hypothetically. Because R is telling different way. If I have a good initial condition, will be solution with no hypothetically possible. But solution may not be because how my observation is. Then observation is how knowledge in the observation. Which parameter would be interacted that observation. So in this way, we have a accumulate, we have an experiment, lot of experiment we do. What is the simple way? So current estimate that has been to 2 objects. We have a current estimate and uncertainty of the estimate. Whatever estimate you are telling, I am not telling it is precise, it's an accurate estimate. Estimate may be plus or maybe minus. So that estimate, how uncertainty estimate. I cannot observe every 1 minute. But what the observation dealing with the time, that uncertainty I should have to understand. If it is summer, then temperature quickly varies. So if winter, temperature slowly varies. So I want to understand this observation, how this uncertainty is varying. If I don't understand that uncertainty, then I cannot. If I tell diffusion case, applied your advection or diffusion case for winter, and same case, if I applied the diffusion or advection equation solved, what to do in your summer, can you get same result? Can you get same result? If you have a diffusion equation, if you solve advection equation, diffusion equation, solve in Gautam Buddha winter time. In your summer time, can you get the same result? Then I have to understand the uncertainty. What is the uncertainty usually? The observation or my model. So this uncertainty, I know this. Okay, I understand this uncertainty. Then I combine. I have a good observation, applied observation, data, compare, reject, accept. These things I have to compare. किसके साथ compare करूँ भाई? आप तो बोले मेरे पास ऑब्जर्वेशन नहीं, आप मेरे को ऑब्जर्वेशन दे रहे, मैं इमीडिएट बोला भाई मैं कंपेयर करूँ, who will compare? Me, I am a good person. How I know I'm a good person? I compare with you. Another one. How we compare? I compare with ideal cases, ideal solution. You know, mathematics, ideal flow, ideal Labna flow, ideal solution. Where I get the ideal person? If I ever telling Gandhi is good or bad, people are telling, then who will be ideal person? Who is the ideal solution? Tell me quickly, otherwise 1 hour will go over. Then I have to conform. See, but not on see. नहीं ये देखूं देख रहा हूँ ये गलत है लेकिन ये नहीं देख रहा so I have take some NWP output I know my equation solution is solving certain extent there is some uncertainty there but I have to take then I compare climatology value of Gautam Buddha University what is the temperature what is that to compare that operation if comparable within 5 plus minus 5 standard deviation I fix then may reject. Then reject करने से पहले I'm thinking because I spend lot of money to get this observation. I cannot reject. So I have to think about it. So adjust. How will you adjust it? So lot of mathematics is used. Lot of algorithm is used. Lot of thinking is used. How to compare, adjust. That is a really complex thing. Right? So after all this done, then so let's see my state of my objective was what? Two objectives. Current state of atmosphere should be good and my focus should be good. Because I know at certain extent I cannot solve or I cannot get approximation beyond that to solve what nonlinear equation. Yes or no? So here these two things you have to then I got a estimate of a state of the atmosphere. That means two value of atmosphere. Then I put this two value to my equation. Definitely, no. So you imagine this is the flow. Yes or no? And globe we have already talked about the variables. We have a latitude, a longitude, latitude, vertically. Then the globe. In the India, different language, different dress code, different food, different land. Different. If you come to my state, it's different. If I go to UP, that is different. If you go to Madhya Pradesh, different. So same equation, same advection, same diffusion, same parameters, whether it is applicable to Himalayan region, whether it is applicable to Rajasthan region. That, our become was not. Yes, this globe, our India, if you think about India, three sides is ocean. One side is hard pole. We are calling this is hard pole. We have a in meteorology three pole is there. One is south pole, north pole, another is south pole. We are talking. We are more focused in our hard pole. Listen. So third pole, how you solve the third pole problem? How you solve the ocean? You have not still 1% study above the ocean. We have not get any good observation over the ocean. But everything happening in the ocean. If you have a cyclone, if you have a El Nino, Enso, monsoon, all this happening over the ocean. So how is it? So this is a very complex system, not an easy way to tell this is good or bad. So I leave it to ocean, even to our surface. So your surrounding is a small lake. Pool is there. The temperature or other patterns, temperature is different. So this type of thing has a great same equation which is solved then it is a problem. So have to add some more land use, land cover, land information, soil structure. If you go to Rajasthan, too hot morning and evening too cool. Yes or no? If you go Rajasthan evening winter time, it's more chiller than the factory. And 10 o'clock it is too hot. So this kind of a situation is happening in the factory. So okay, everything is happening. I understood all this in simple way. I have the observation and I have the sound issue. Yes or no? I already thought I have a lot of observation. I have a diagnostic issue. Highly situation, which is doing then the variation of temperature, height, air constant, potential temperature. So domestic equation, diagnostic, prognostic. What is the difference? Okay. Here, so it is any time is equal to temperature. Capital T is temperature. Here there is no time. If you go to thermodynamic equation or something, then it is equal to time equal d by dt, which is time. So this equation, I have this equation. It has a time level, then I will predict the future. Today, if I have this, I give it G value, P value, and all these things, then I can predict what will happen in tomorrow. Yes or no? So then I have the observation. Then observation, how accurately observation, that is good. How dense is the observation? I told in the whole Noida, only one observation. Right? Maybe Gautam Buddha district, maybe one or two. Even if we are taking Meerut as in the district, Ghaziabad, then only one, two observations, four observations. But it's a 1,000 square meters. 1,000. So how do they related to state variable? If I observe something, if it is model will understand only these things. It have a radar. It will not give you PET, basic value. It will give radial velocity, reflectivity. Right? To understand radial velocity, it is not actual velocity. It is radially कितना दूर जाए observer कितना दूर देख रहे हैं, right? So here this is not. I have to convert that information to my basic variable. So conversion is also a useful algorithm. I apply certain algorithm. So these are the direct observation we are getting from heat observation. Those are reactive, but it is very fast. It does not cover all the regions. So then satellite will be given the picture. So this observation, I know there is a some error. I introduced that. Why? The observation SF plus S is my model. Observation is not at the model bridge. So how will we take this model of information to observation? So that is another non-linearity I will introduce. Who will bring model value to observation? Because it is different degrees, different places. So that another operator introduced, that is also model. So many non-linearity principles. And each has each grid point, each model point, it has a thermometer and observation. So there is no need of observation. So I get accurate observation. So but this is not true. So that's why we have to apply certain algorithm to accurate. If I have applied my thermometer, then y and x model value and the observation is the same. Then you know, this satellite is certain different, then I have to calculate this because this one x. This is the y matrix value. So how to solve that matrix? So these are the error. Model also I already told we have the error. So observation error, model error, then combine all these things. Then we have a chaos because I have to predict the future. Then we can we determine absolute situation? No, cannot be. Whatever you apply. So this is very simple example. If my initial condition to have less uncertainty, then I have predict it's a critical function. You people are telling. I'm not telling. If my initial condition is good, initial value is perfectly I provide to my decision adversary, I get a good solution. In based on that ensemble prediction system, all these statistical method I could get. So one scientist learned butterfly effect. This is more predictive, yes, pattern is followed. This is less predictive. This is totally unpredictable. Right? Florence has developed that type of butterfly effect. If this type of pattern is coming, it is predicting well. When that model is going to be yes. So based on that, so all the methods are developed slowly. So I'll not go this. So we have a forecast model, we have observation, then we have the accumulation. Okay. So I come to this. Yeah. So you see, my observation like irregular. I cannot tell you my grid function. How to transfer this irregular information to a regular grid. So that information to apply whatever I talk thematically. And these are not direct values, certain satellite, radar, these are not direct variables. So we have to convert that direct variable to this. So numerical forecast is have a tell observation we have the analysis because we have to represent our initial condition. It's initial feature of noise, you have applied some noise filtering because all equal then have to forecast. So many methods developed and how you have to forecast it. You have to prepare your initial step, calibration, validation your observation, and observing system design. Once if you have my whatever observation I am producing, which have not utilized, can be issued. So different method are getting. Empirical preparation method, logic. When I am working these two methods, slowly I will see how we are repeating. Okay. So lot of method developed because of how to interact with non-linearity and empirical. Develop how to incorporate observation, different observation, different information. So lot of observation is coming. So variational assimilation is now it have an optimal integration Fresnel technique. Maybe you people understand Fresnel. It will fix a radius. Within whatever radius observation or information will be inserted. Here that it will not incorporate that thing. Okay. So but if you have a thunderstorm activity in Noida, you are getting a cold breeze open to the better noise. That information you add to you. So if that information not incorporated in my model, then how will it be? So that's why variational assimilation is the information, whatever observation, whatever information I have to distribute that information to all my data with certain weightage. Okay? Because weightage, if you have a Noida, have a thunderstorm heavy rain, I will give you more weightage to Noida. Slowly the weightage is how to define it. This is another number. So many nonlinear things are incorporated in the model. Okay, one by one. So finally our objective is what? To get a good forecast. So cost function can use same while put in a new but cost function is not new but how my observation model value will be minimized the error. Okay, so to minimize the error, if I have an equation, left hand side is equal to right hand side. I want this left hand side will be become a 0. Then we get the exact solution, yes or no? So d by dt to solve this equation. Then I have to take d by dt of right hand side to solve all these equations, so non-linearity and all these things. So how will we solve this? I want delta z to be equal to 0. Then I get an exact solution. To get a 0, I have to derivative this. But these two are very unknown. The first part is model, the second part is observation. How I got this equation? From least square method. Okay. This is student. For student it is just how I got this equation directly. This all is for least square method. Okay, if you not solve, just follow my one book chapter which is chapter 50, which is how I got this equation from this equation. Okay, so once I got this equation, I will not show this mathematics. This is model and this is the actual. The problem is here, I can solve this transpose and why I will take a same transpose system with mathematics. Once they will be here and these are the observation background error, means model having error, and there is the observation error. This model error, as you imagine, this is 10 to the power 8 now. I will solve this matrix. Whatever data assimilation I will show you because of this person, this parameter. Okay. Variational, optional, hybrid, ensemble, successive correction method, because of all these matrix. Okay. All methods is developed because of this error. How to handle this? So when we solve so here is problem. If I solve part by part, model part, I solve this. Then I got exact solution. Which have this solve the Newton Stan method, CG method. Are you get a exact solution? After because the curve will be down, then again at certain point it will be again steady, then it will be right here. Right? So if I solve this one by one, then I got a one solution here. And let's observation, then I have the clear function I have to see. Right? So it is not fun. When I combine this, the solution is cross point is here. Because of analysis, but I have both the J and J. If you have a process, you can equal. If you solve that, you have to need something. You have need to mathematical solution, you have to have an observation. So a lot of things are there. And I leave here that you get over. So this is the schematic, those are working on this. So I will not go through all this again because this is the base. So go through that PPT. My email is already, you can agree with, you can ask. I'm frequently coming also with you because you have a collaborative. This can be. You think about it. Mathematics is not on paper and pen. You have to think about my mathematics to solve the problem of the real life. Understand how you answer that? Not partial differential equation, not the eigenvalue, eigendistance. You are the most easiest person in the real space. Okay, thank you. Do you have any questions?
Thank you, Ashish. Any questions from participants? Yes.
For second question, how do you know that the data is there any general?
The general, hypothetically, we are telling Kodivary as compared to why. So you see this is the one.
नहीं,
Ma'am,
So that is the keyword.
नहीं, this is a very good question even.
this schematic, what is happening? This is trivial and trivial. So what is trivial? Traditionally, understand, I vary everywhere my information to everywhere. Okay. So why is 3D? 3D means 3 dimensions. I know X, Y, Z. X, Y, Z. Okay, no? One variable vertically, one horizontally. So that's why I put this 3D. But my objective is what? Metrologist objective is not to do. हम समझे नहीं, हम दूर के टुडे जो हो गया मेरे पास इंफॉर्मेशन आ गया हम देखेंगे मैथमेटिक्स फॉर टुडे आई सॉल्व दिस इक्वेशन बट माय ऑब्जेक्टिव whatever information is due I want to see tomorrow day after tomorrow maybe 10 days maybe 30 years what will happen hey so when I am thinking about the time then I include one time because I am thinking of tomorrow thing. I'm not worried about the today. I'm thinking about tomorrow. Then I add one another. Then what will my dimension will be what? Okay, no, my time के साथ. Then time के साथ वो involve किया. When I'm considering three dimension, I ignore the time. Time is gone. Time is constant. Yes or no? Simple. Time is constant and my three dimension is constant. Yes or no? Time is constant. I fix my time. Whatever observation coming, I consider this observation for this. Okay. Generally, operational methodologies का 3 hours before and 3 hours after observation को लेके बोलते हैं कि इसी टाइम का okay 2:32 8:30 observation is considered as IQ. यानी कि 2:30 observation and 8:30 observation is the morning 10:30. It is summer time 8:30 maybe talking about 32. 5:30 is maybe 27, 28. Okay, no? But I am considering it is the same observation. So then I combine all this information here. So this observation information, whatever is 2:30, is considered as 5:30. It's not correct. My algorithm developed, my computing circuit developed, then what I am told, now wherever observation, I will accumulate that information and it will go there. Then my model, accurate model will be built. Then no observation, no observation. Once observation is off, then information, that only the observation. So what is that? It is having 2:30 observation information at given the 2:30, not the 5:30. 8:30 observation at given at 8:30. Then I finalize 8:30. That's why the information why 3 or 4 is good because the time variation of observation. Simple way, lot of other logic is there, mathematical logic is there. Yeah. But simple way, it says not consider time, it's considered. Whenever observation is that, the model background is the observation. That's why that information is another many things are there to test and all mathematically solution, but it's too much to tell. Okay.
Thank you.
Thank you. Thank you. Have a good opportunity to meet you people. And generally, I'm also love mathematics, but I see just the methodology to utilize the application. Okay, 2-dimensional specialization, 3-dimensional numerical. Then when I asked my professor, where I will apply? He told simply, you apply in rocket. Okay. 3-dimensional and numerical, mainly using rocket. But when I came to AIU-GBU, then I know 3-dimensional numerical machine. I said it. Thank you.
Thank you, Ashish. I think it's a very nice lecture, very informative. And now you see there is a lot of hope for mathematicians. There you see the real application of applied mathematics in terms of they are working in partial differential equations, numerical analysis, fluid dynamics, even in analysis. It's a combination of
I mean, there are a lot of things you can see. The Ashish in his lecture basically gave a very broad, you can say, the idea for the PhD students or faculty where they can apply, they can continue from their expertise in how to predict atmosphere in an accurate way. And he showed only one of the, basically he focused on data assimilation, how to improve, see how the initial condition is so sensitive for the differential equation to be perturbed slightly, then there will be a lot of, change in the final solution. And that is, which is given by Hadamard. Usually I told to the students and I can't control the partial simulation very first lecture. There is a well coordinate. And well coordinate is the third thing is the stability. And this is always the stability which is given by in a closely sense by Hadamard. So what he says is if you your final solution, even a solution should be continuously dependent on the initial. Then you will say this model is well posed. Basically, he was telling about the well posedness, the third criteria of the well posedness. Normally, the numerical analysis is ignoring this feature, and this is one of the important features in numerical analysis in atmosphere. And how to highlight these things very well. We have minds, we have political persons, we have statistics, but we are sometimes ignoring the sensitivity of the initial thing. But how to accurately do the more accurate initial conditions using the observations from different sources so that you will get an accurate picture of the atmosphere after 10 days or after 1 month. That is always a challenging task. So I think this is a very inspiring. This is an inspiration to everybody how he highlighted these concepts in his talk. So once again, I thanks to Dr. Ashish Kavure this FDP program. Thank you so much.
And the next talk, there is a very senior professor from GNU, and we will start soon within 5 minutes. Please be here. I'm telling to particularly the online participants, please be stay in the group. Good morning, everybody. Now we are on the final day of this FDP program, the FDP on Applied Mathematics in Interdisciplinary Research, Theory and Computation. On the behalf of organizing committee of this FDP, I welcome Professor R.K. Brojan Singh from JNU. And I also welcome all the faculty members from Physics Department and the students from the Physics Department. It's a very, I mean, after a long time, we are sitting together for any academic or a research activity. Thank you, Professor Mosmi Kohiji. And now I request you see, just I give a brief idea about this faculty development program. And it is started on 8th April, inauguration at 10:30 by Honorable Vice Chancellor Professor Rana Pratap Singh, who is also from JNU, and the guest of honor Dr. B.S. Prasad, head MSMW. And after that, there are lectures by one faculty from our department, Dr. Amit Awasthi, then Dr. Rajim Pratap Singh, he is also from JNU, from same center. Dr. D.N. Pandeji, he is professor from IIT Roorkee. Dr. Kedarnath Das, NIT Silchar. Dr. Atul Kumar Sahai, scientist G, and he has a very wide experience in the application of applied mathematics in weather and climate. Dr. Abhijit Sarkar, again senior scientist from NCMWF. Dr. Vivek Singh, IITM Pune. Dr. Amin Singh, IIT Delhi. Dr. Asif Chowdhury, scientist G, and Professor P.V.S. Raju. And now the evening we have Dr. P.P. Singh, again senior scientist from MOES, Government of India. And today in this session, we have Professor R.K. Brojan Singh. So I request Ms. Pratibha, please brief about him, about the speaker for this session. Okay. Before I request Dr. Mosmi Kohit, please give a small tip from the FDP side to Professor R.K. Brojan Singh. Thank you, ma'am. And now I request Pratibha, please brief about. Thank you, ma'am.
Very good evening to all the participants. Today it's very easy. It's honor for us and a very utmost privilege to welcome Professor R.K. Brojan Singh, an esteemed scholar, accomplished researcher, and dynamic academic leader from the School of Computational and Integrated Science, Jawaharlal Nehru University, New Delhi. Professor R.K. Brojan Singh is a faculty member at the School of Computational and Integrated Sciences since 2013, and he joined as an assistant professor by then, and now he is a professor. And Professor Singh's academic path is marked by an earnest PhD from Newton University, and had a fourth position followed by MSc in physics from Jamia Millia Islamia, and he awarded the gold medal with distinction, and he completed his PhD from School of Physical Sciences JNU in 2004. His area of PhD thesis is theoretical condensed matter physics of two localizations of 2D and 3D in a thin theory. His postdoctoral experience spans leading global institutions, including the University of Technology, JNU, German in 2004, the University of California, San Diego, then the Center for Computational Biology and Bioinformatics. Third, research interest is very diverse and very vast, namely stochastic dynamics and modeling, system biology and applications, nonlinear dynamics, factors and multifactors, models and applications, population genetics, theoretical condensed matter physics, complex networks, and cognitive neuroscience. And he has contributed extensively to this field through numerous peer-reviewed journal articles and publications in the book. He has successfully led 5 major research projects funded by GSC, CSIR, UGC, UQ, and others, and is actively involved in national research networks such as National Network for mathematics and computational biology. In addition, he has made significant contributions in editorial board members of journals, including Journal of Big Data and Computational Science, Scientific Research Publishers, and International Journal of System Biology. And he is the board advisory member for various public and private sector institutes. Professor Singh is also a frequent invited speaker at prestigious national and international forums where he shares insights from his interdisciplinary research work. He is the recipient of various and numerous fellowships and honors, including the FDP Free Fellowship from Germany, then Roman Postdoctoral Fellowship, then FDRC Fast Track for Young Scientists, and a visiting research fellowship to the University of Sydney. Beyond research, Professor Singh is a dedicated mentor, having supervised multiple PhD scholars working on complex systems in biology and computation. We are deeply honored by his presence with us today, and his vast knowledge, academic leadership, and research vision continue to inspire students and scholars across the discipline. Please join us. Sir.
Thank you very much for the nice introduction. And thanks a lot to the organizers and especially Dr. We can some of the research work which we have been doing in the campus development. And the students and want to follow you today's talk is a little bit away from the traditional physics, but the idea of some part of the physics, some part of the mathematics, and some part of the chemistry, such area of the complex system should be so I will try to make myself straight down edge so that some of the things from the practice and physically should be understood for us and the learn together. And I will also learn from the questions on the procedure. So let us have a interactive kind of talk with faculty, and so if you have any questions and comments, please do copy the invitation. Good example. So the title of this topic is Taking Embedded Systems and the in this particular problem, because you know that competition is hard kind of idea. I will be giving you the concept, and it is extremely hot area nowadays. Since 2021, there is also the cooperative. So from the those also from the civil. For two particular for each particular taking one of the and from that only this competition kind of studies in this area. But before also it was there. In our school, from 2006 onwards, we had like that Center for Competition, one of these competitions. So now let me try to see how the definition of the competition. So if you look at competition, this complexity, the meaning is that this is a technique what literally meaning is an important. This thing, it has two basic realities. One is that in the process, one is to define the system. The system is nothing but it's some very previous kind of the system is nothing but it has two entities. One is the number of entities for the healthcare program, and the entity is very different. So only the time one can talk about the system. And so this complex system it should have at least 2 and more, you can say, objects or class of components, that is partly construct for a particular system to have different parts. And then those parts or components are well-defined kind of instruction. And then it is the instruction is in such a manner that one cannot see that those components are separate. No, these are all the integral part of the system. And then there are many examples of systems, starting from the microscopic system, that is cellular system, which is meter of health, to human society, and then social relationship, then economy, then climate change, and also systems that large number of the systems are there, where one can always define the system. But however, in this particular thing, this components in this systems are well organized and well kind of connected, because that every individual function of the components are similar. The only method is that what is the overall function of the component, which is generally known as the emergent. The emergent property is the most important thing in the composition, and it is not much important in the individual component function. But however, there is no one defined definition of complexity and the composition till now. But one can always talk about quantified distance, that how can I what is mean of complexity? Then if you are given a particular system, then how complex that complexity is. That is the meaning of the complexity. That can be done such that if the number of nodes or number of components in that complexity is increased, then complexity also increases. And if the number of connections among the nodes, it may also increase slightly, increase the degree of complexity. And if you pick up any two steps of the particular system at infinite time, then there are infinite ways of different from the particular one system. I'm giving you one example. If you talk about one word, one thing that is taken to the best and other thing to the right. Then one can always think about it. There are two. But if you talk about what is in between these two, then depending on the angle between this part and the head, then it is significant. So that makes the system more complex. It is for only two cells, but in between there are infinite number of differences overall. We can also infer in the traditional husband and wife argument. For example, if there is a fight between the husband and wife, so there is a but whenever the fight is going on, maximally 99% of the fight is not over by saying that you are wrong and you are angry. This kind of thing. It is always in this. There is also ego. So that kind of ego is always there. And if you one of the most important property of the complex system is that individual components get no linearity. Because of this non-linearity, the system can elevate in very peculiar and very interesting system. For example, if you talk about this linear system, it is always called map xt plus 1 equal to r xt. This is a linear map. I is a constant parameter, and for different r, if you look at it, it is linear equality origin. But if you get a particular non-linearity term, which is called r xt square, which is non-linearity term, then the system is absolute. For different values of r, you can see different properties. For those properties, you can see sometimes periodic kind of behavior, sometimes it is chaotic, and in the error also single seven, double seven, triple seven, so different kinds of properties observed. And you can also observe different properties of the biology. And then if you increase, then the degree of the non-linearity is given by the beta. And then as a function of I in this parameter space, you can see a lot of distinguished properties. Starting from the, you can say, monotonic damping oscillation and certain oscillation and any kind of, you can say, chaotic behavior, many other things, depending on the value of the theta and the delta. So, what I mean to say is that the nonlinearity and the degree of nonlinearity is one of the most important parameters which explain different properties of the system. And then another important property of this system is the ability to adapt. For example, let us say if there is a particular system, if you give a certain population in the population, if you always talk about that, if the population is here, then that particular population is moving around in the population. And then that particular population will give rise some kind of modification in the property in the global and the local. And then if it is local property to propagate from that particular epicenter to others. So there is a change in the global, local and global. Then the system receives those kinds of changes in the system. And then the system, what does the system does is that if that particular change in the system is changed, the system will adapt to that particular segment and it will incorporate. Otherwise it will be different. That is called adaptation in biology. We are taking those kinds of changes from the biology. And so those things are actually in the computer. That is called the ability to adapt. And another is the self-organizing. Self-organizing in the sense that, for example, it is taking a particular system, and then the system itself can able to do different variety of stuff. For example, it is a philosophy. In the cell, if you look at it, it is for equal to 14 molecules are here, and they are working in a certain coordinated manner that particles there are multiple molecules here. Those things are incorporated conventions. And they are self-organized. And the definition of self-organized is that very physical and mathematical. If you look at it, this kind of organization is structure. There has to be certain structure that is called level of topology, and that depending on that structure, it has a partition. And so these two things are somehow interrelated, and it can be perceived from that system. And that particular things are systematically organized inside the system, and whatever emergent property which that particular system is giving rise is due to the self-organizing behavior of the different multiple functions here by different functions. That is the emergent. For example, let us take if I give you one example, bicycle. The handle has different functions that is giving the direction. Wheel has rolling, chain has connecting the two things, and so on. Different components of the circuit has different functions. But if you look at what is the function of the circuit, it is rising. The rising is the emergent property, and it is completely different from the individual functions of the component. So that was the idea of the self-organizing. And the another mathematical definition of the self-organizing is that it is a stencil. Stencil in the sense that if you change the cell of the particular system, the properties will be. For example, let us say if the f, which is f is the function of the there, and if you shell it with the alpha times f, then alpha times of c will be there, which is the cell factor, and the fx, which is the initial probability. and you check that translated or check it somewhere, but the property. That's the property of the important distinct property of the cell. Now let us try to look at few interesting numbers. If you look at the universe, it has around about 10% it is called observation universe. But till now, we do not have the complete number of the universe, but what is observatory universe, which we can observe from the surface of the Earth, which we can observation. It is roughly you can call 12 galaxies. Yeah? If you look at galaxies, round about 10 to 12 stars are here. And if you look at human population in our solar system, it is round about 10 human beings are there, which is 2 billion. That's it. And if you look at one human being, step down, then we have 10 to 13 to 14 cells are. And then if you look at one single cell, then you will have 10 to 12 to 14 biological. And if you look at one that is DNA, which is in the size of this picometer in the nucleus, if you look at, if you count the number of nucleotides, then it is around about 10%, and the length is around about 1 to 2. It is a very, very complicated kind of structure of this company observed in this case. Then, why I'm saying this particular stuff? It is that if you scale the cube, if you look at the number, if you scale, what is the largest scale, you scale down, scale down, scale down, scale down, till the nucleus of the cube. The number is somehow small. That means that what is it indicates? It may be there is no certain physical or the chemical kind of differences. It's not there. But the properties of the universe can be like this, that can we study the property of the universe in our lab by studying the properties of the universe. That was the question which one had to answer. Because it is a still factor. It is still the property of the universe. So that is the future question which I'm also asking myself. Can we study the universe by sitting in the lab studying the universe? So that's why cell factor is very, very important in this question. And if you look at it, now another thing which I want to say is that there are institutes we know that there are roughly 3 parts of the class. Practical particles is what we the mechanics. Other particles which are which always coming from the and then in this. This is called microscopic particles, and we generally call it stochastic particles. Why is it called stochastic particles or microscopic particles? These particles are generally influence substances. The particles which is influence substances, they are generally known as differentiating stochastic particles. And so stochastic particles are somehow and if you look at it, in terms of the size, it is sometimes it is from -6 to 9. And how do they describe this kind of dynamic of this? It's neither obey classical laws nor fundamental. Then there should be some kind of mechanics on this kind of dynamic. One interesting area was the physical mechanics try to define the dynamics of this particle. But we have to borrow techniques from different because especially statistical mathematics mainly from mathematics from and many others. What has to be incorporated is also that we follow the discussion. Another problem could be that the bulk system, since the particles are self-automated, kind of, that they have the utility by moving, if you cannot stop it, it has its own utility. You can have the idea of living there and there. It is not just like marble system. So that's why it is very, very difficult to find out general principles or dynamics or general governing laws of balance. So in that sense, we try to see some of the things which one can apply the stochastic analogy in such type of. And just in beautiful results one can see the chemical working. And if you look at one single cell, you can give you chemistry level kind of calculation. If you look at the mass of change in this, if you follow the molecule, then you can always calculate the number of particles in the and you can see this in this calculation. And then all these particles are surrounded by fluctuations, and giving you different types of fluctuations. One is standard or temperature fluctuation. If you know that it is temperature, and the cell number fluctuations are there. Why cell number fluctuations are there? If you look at different cells at different times. For example, if it's blood cells and 30 days, red blood cells 1 degree, yellow cells at 80 days, and then different and if you look at this overall kind of thing, you have average number of cells there and regeneration frequency available. This is very optimized every day. Our human beings, there are roughly 10 for 11 cells. The 10 for 11 cells are in region. It's really separated. And the third, fluctuation is given by acting pressure. For example, if it is pulse over here, and squeeze over here, then cells can squeeze or expand. And the cell phase change is very, these are all essential ingredients. And it is 10 to 50%, then the expand also. And if you expand, the number of particles will be basically will be rare, and it is control frequency. And so these are various experimental evidences are there. Neurons, you know that this particular concept neuron, it is for that person got in the you can say it has to be meaningful, and that is a fact that for one neuron cells for the 20% has to be meaningful, and the somatic cells that is around I think it can be in concept of and then how to write incorporating those kind of practices. If there are any possibility of knowledge, for example, see some of the possibilities observations and then techniques. Because if you look at it in 2000, both generation of 2020, when that is done, this is the kind of video net. And if you look at it, this is the database network of the solution. And if you end up anywhere, you can find different pathways. The pathway, the description of the pathway is that is a certain number of diameters which undergo a certain sort of the chemical reaction. For example, if you look at the leather over here in the pink line, you can see that in the in that way, if you look at this area are this physicists and mathematicians see that this is it is just polynomial. And if you look at this policy, there are two types of things. One is non-basic policy, and the which says that a particular atom A and B quantum molecule A and B collide each other with a certain momentum, and then other molecule they move in different directions with different momentum. But if you look at this particles are very macroscopic particles, and the change in energy and the change in momentum are negligible. Then if you look at this, it is plastic particles. Then they obey all the conventions. Conservation of momentum, conservation of energy, conservation of momentum. And if you look at the properties of such type of crystals, you can see that these properties, these colors obey necessary conventions. For example, if you look at these particles are blue and the red particles are putting this up in the colliding with each other, and then they will and the two plot the distribution function of this particles, then you will see that it is always the same. And another type of golden surface reactivity. This kind of reactive quality, so that may say the particle molecule A and B and like a new molecule C. But if you say that one molecule of A is decay, one molecule of B is decay, and that one new something different new molecule is decay. This is called part of the golden surface. This is actual chemical reaction to the chemical. And in our physics and mathematics, we can reactive quality. And so, if you look at it, these two types of processes, in the natural conductivity, 70% of the golden process is generally golden quality. But only 20 to 30% of the golden process is this reactive. But the importance of this particular reactive quality is that it is the basis of all conditions, whether it is quality or subtle system, any kind of this is the quality. That's why it is very important. And the further we are, I'm going to talk about the better types in the on this particular reactive quality. Okay. And another important thing is that if you look at how to this is some kind of the experimental observation before silver and the lighter the combined together and with your phone it is really and this is this particular better features are coming to the observation of the test organisation. This pattern. So this is the signature of the pattern. That's why earlier we talked about the related conditions. This is of the pattern like pattern. So, and then how to model? The modeling part, for example, if you talk about there are two types of modeling. One is the mental modeling, traditional linear modeling, and what it says that every chemical reaction is given by this particular reaction, where K are the responses and the SIs are the reactions, and the after the arrow are products, and the before the arrow are reactions. The KI and GI are the number of reaction molecules and the products. And if there are 10 molecules are there, then PSI will go and if there are 10 reactions are there, then this type of this type of multiple reactions can be used. And if one can model it by using that, very simple quantity. One can apply it, and then all these reactions can be translated to the couple nonlinear differences. And from those couple nonlinear differences, how do you see what of the differences happen for that? And even sometimes you can also predict which are not forgotten and cleaning the energy molecule in the plant. So that's the touch of the quantum. And then another following one is also which is the area and in this model, that is to say that in the deterministic modeling, modeling with output. In that modeling, the perspective, if it is a multiple condition, the perspective is the role of the perspective is used. And so the property one can get from those modeling part is the qualitative, not the quantitative. But in the stochastic modeling, one has to see each and every individual interaction in their calculation, and one has to model it and try to see the trajectory of the event. And then one will see very interesting features which is actually driven down. The perception nowadays, sometimes I need to tell to my students that just like the four-dimensional system, S1, S and T, four-dimensional system, just like that, there should be some kind of possibility that this could be one in the system. But it is not totally not necessary or. And what one can talk about is that this chemical reaction in this particular picture, which is a structure-physical kind of dynamic, all these chemical reactions, which is because this particular chemical reaction, every chemical reaction is the construct of the and then that particular event can be started to the second stage by the step A, B, C, and D. And then from this positive state, whether we get a particular positive confirm that this positive in this positive all this event is satisfy the synapse. But once it satisfies the synapse, then it can translate to the state within dual neuron by the positive. And then one can by analyzing the time devotion of the positive, one can evaluate about how do this kind of events take place and how do this event evolve. That was the crux of the stochastic modeling, because it was in Colorado around the 20%. Then coming from tomograph in the differential form, one can always talk about the property, usually know that if there are 10 number of random variables are defined in the calculation of field, then those random variables and their algorithm also can be another element, which is defined by the function. That particular function is defined by the set of the random variables which satisfy the mapping can be used by the observation. Observation is the fact that which can be actively observed. And so that kind of function is called effect, and this expectation value of this effect is the observed action. It can be observed action. And if you talk about the translation of this observed activity of the observation of the effect, then one can by doing some kind of algebra on the process theory, present is by doing the very simple traditional mechanism quantum alloys this complex combination. So you can find it very easy, you can find it in the complex book for LW paper which was published in long time back So those kinds of in this particular crux of this particular thing is that the first part, which is the derivative, is coming to discuss. This is the part which is goes to the determinism, which is called overcome. And the overcome position is approximated by neglecting the jump process of the particular and then this overcome position is very close to the system. And if you neglect the dynamic instead of the system, then that's the market system, which is the process, which is actually driven by the substitution. So we will be using this particular market system And for the simple, except for the simple question, it's very, very difficult because if it is a new goal kind of problem, it's already solved. But for simple system, we can solve it. And we can do that. And in such system, if you look at how to apply it to the class of the if you look at this particular simple VFC, that's what y is, then one can define a complex method, random variable xyz, and then this xyz is the set of the sequence of the line, and then this particular set is mobility. And so depending on the reactive over here, the potency of the this Q can also be. For example, if you say once this particular reactive is higher, then 1 molecule of X will be low, 1 molecule of Y will be low, then 1 molecule of Z will be zero. That is for example, if you start with this excitation, then in the next time, the potency of the X will be decreased by 1, and this is Y will be decreased by 1, and the potency of the product will be decreased. And some sort of event to the multiple parameters. And then we can always use this particular process in the simple process method. We can use the idea of this want to say, but macro process is only 1% of the location in this function. 99% of the location is not. But macro process we apply it because it is easy to calculate. This is the system of the that's why we use that macro process. So we are going to do only 1% of the. So if you apply the macro process, then you can apply this macro. Now, this particular the general formalism of the solving this particular macro process is taking a very different process, and this is second class of and the transfer from the text to this particular situation. But there are other methods also one can use. For example, you can data function, for example, you can but this one is much simpler. So let me give you some of the examples, and this one can apply it to some of the interesting things. Let us say a particular in this particular field cell, there could be different types of things. One is a molecule, other is human. And out of 10 for 11 to 14 molecules, and just picking up 1 or 2 molecules, which is a molecule. Then another molecule, which is repeating 2 molecules, for example, that is it. And then once it is coming from the extracellular medium, then this red will interact with the molecular state is same, and the molecular state just after interaction is same molecule by this activity. So when it exactly the molecule in the medium state, it will reduce. It will increase this number, and it will that particular molecule this molecule is going to be it will be decreased, and it is two molecules in that then this particular reactions are absorbed oxygen. It is stored in photocatalytic. Photocatalytic reactions are considered to be the integral part of the biological system. In this, they automatically help create the molecule and the inactivity reaction. And during that process, certain important functions. These are all ethnically observed kind of model. And then if you look at it using that partial multiplication convention, one can always, if you say, if you think about this A and B are very large, very large, then one can always think about this multiplication
And this matrix can be treated with the one-dimensional representation can be used, and then you can solve it. It can be transported to G, and then this can be solved using the Lagrange bracket solving. And so, if you look at this particular G, it is a very structure kind of mathematical structure. And from this G, one can easily calculate the probability of the X interface molecule in this structure.
How these molecules are interacting? What type of interaction in terms of physics is there? How these molecules interact themselves are interacting?
Yeah. So,
Electromagnetic interaction.
depending on the protein is composed of a large number of things. And so when they allow to interact among themselves, some are covalent bonds, some are covalent bonds, and some are polar coordinate. So different types of these interaction actually exist. So electrostatic interaction coming into the picture, bone chemistry is coming into the picture, and there are many things are coming. But here, what I'm talking about here is that all those interactions are making a complex one, and it is evident that by following all those different types of interactions, you can take two concepts, taking everything on.
But we must be defining the interaction or writing the equation.
Yeah.
So how you are basically taking into consideration that particular interaction?
Yeah. So those kind of things, if you look at it microscopically, the data process. You know, in molecular dynamics, portion of one molecule or molecule A, portion of molecule X are already common. And that particular portion is a long kind of this involves electrostatic interaction, electron shifting, then all those different types. But here we are saying that those kinds of interactions are involved in the interaction. And because of those things, this kind of chemistry function
Range of this interaction is 2 nanometer, right?
yes.
Or less than nanometer.
You can say that at most parameters
So is there any possibility of like poster type of interaction or vector type of interaction?
there is a possibility. In the problem it is very easy. But some of the things by allowing those kind of interactions, we get the different parameter values of the voltage. And so molecular dynamics is one of the other questions. So we usually use but anything that molecular dynamics is also properties not much less than and even vector function very those kind of functions.
So we are not factoring quantum mechanical interaction.
No, so it is invisible. That's right. Yeah, well, yeah, definitely. Yeah. So what we do is that we collect those activities. In the photo calculator, we get all those activities. And check whether those parameters are satisfying in the simulation. And whether it is matching with the actual experimental model only. And this simple model, it can somehow and so it is generally accepted model. It is a stock model. It is a stock model. It is a model which is and then from this very complicated expression, can we think about
different certain species. The first certain species contain extra because two different species numbers make it very, very, very nice. So go to giving this kind of model, then you can adjust frozen. What we are frozen. And if you look at this number of particles is very, very large, and the different particles is very, very large. This is so fundamental. Where the quantity of the approximately every time you can the memory. So these are the this drive that some of the activities of the property activity. So from that we generally do the role of the property, which can be estimated by the concept of in observing in trying to understand that nuclear to change the nuclear economy. That property is can be calculated from the mean and the median. It can be calculated from the percentage frequency, and then you can check this particular expression for the factor, and then from this factor one can evaluate of the three different properties. One is that it gets close to one is the property. Less than one it is the subordinate process where the whole of the is not evident. But in the case of this process, there will be one. It is all noise enhanced. In this kind of noise enhanced process, one can always observe the distributed structure in the particles moving to the concentration. It is all significant. And it is away from the individual. And then another example which one can talk about is the wind expression family. And it's very simple and it is a large number of our human beings that form a different target and in this kind of field it is called simple dogma. It says that from the particular gene it is transferred to the RNA, and the RNA is transferred to the copy, and if the copy is not misfolded, then it is the copy copy. It is misfolded. I guess we go to the polygonality. So this is what we can do. Otherwise, it will be for example, if you look at this particular problem, you can always consider from this sequential reaction on this for continuous system of this particular classification, and you can use the dimensional reduction from this unity with our two parameters. You can reduce this two parameters by solving the problem. And then from the reduction to the one will derive from the concept of reduced mass efficiency. From this reduced mass efficiency, you can easily solve the process. And if you apply delay over here, then what is the meaning of delay is that some of the reactions are very, very quick, and some of the reactions are very quick. And then if you compare the two types of reactions, then the first reaction will be only reaction. And so in order to capture the dynamics of this first reaction, this flow reaction is divided into a number of steps which can capture which is of the similar to the substance. That number of steps what number of things between the constants. And if you apply the substance on this is a clear method which involves T and the other parameters. And then within the condition, then you can easily consider this expression in G, and from G you can also use within this particular statement, and then from this G you can consider the probability. And in this probability distribution also you can observe the pillar pattern with the average number of the RNA The very last, and the very last is one of the presentation, and it is the thermodynamic unit, is the unit. That is very important. And the purpose also one can follow classes, then you can do the conceptor, and then in the conceptor also to do complex process, and you see the role of the voice is evident in the complex process, is inside in the system. And then this is the example for the simple one dimension or multi-dimension concept. If you look at multi-dimension, this combination is different. In those cases, in those cases, the effective story is properly and I'm giving one or two examples from there. Can I take 10 minutes? I'll make it sound. Okay. So I'll make it. So I'm making fast, very good already. So we are applying two different models. One is the overall sensor, and overall sensor is very human, and it is one of the fifth technical interview. And if you look at this particular thing, you can access the data from this content. There are very six databases are there, and where you can see those experimental things we can here. And we accept all those data, including verified data from this databases, and construct a network by you can say taking those kind of that is involved things, and the principal things contribute to we use the six of this community and try to see which thing is that was the of the team, and we propose one particular method to get person method and secret that other person method. That is that every get particular section network we also put that certificate has to be where the different modules are modules are subtypes of modules and so what we do is that we integrate the entire this network to different levels of the organization. They can communicate through and then try to test which are the bits which is present in all the systems that are the multi-zone data that one. So we do that, and we follow this concept of the thing. This is the structure of the overall consensus. This is the family network. This is the subcategory we should able to get all these patterns over the forest. That is the pattern. That is the second pattern which we observe it, and all these patterns in the there's a compound because and then this kind of thing you can see all those artificial phenomena of the different types of the so they are also and then if you look at the different there are three types of the and the solution first is taking the one part of the and then you should be able to find out
these are the students who and that wanted to I would say only wanted to regarding our school. Our school was one and what renamed is School of Education Sciences. And we have a large number of education members who are from private schools. Biology and computer science engineering programs are here, and they are working in different such areas in this school. And one of these such areas is agriculture, communities that wanted to also in this school. And there are three courses of course. One is MSc Computation Market, and the other one is to be diploma in different competition and we have competition facilities. We have a high option here and so library here and the high
Thank you, sir. This is very elaborative talk, and I saw there is a lot of mathematics. Now we use the mathematical tools in various applications and including the solve. Is there any question from the participants or any comment from any physics, faculty or student or any or we are trying online? Any questions? No. Okay. Thank you once again. Now I request Dr. Manmohan Singh to give a memento as a token of honor to Professor R.K. Brajan Singh.
Thank you, sir.
Thank you, Manmohan ji. And once again, thanks to all, particularly these faculty members and students. Thank you, sir. Now we will join for the online participant. Again, we will join at 2 with one lecture and another